Alright, so I just want to show something quickly around correlation. If we had a set of x and y values here, and we didn't graph our data to check for linearity, and we just blindly went and decided to calculate correlation, if we did it that way, we still get a number, okay? Still get a number. Here the number is negative 0.12, essentially. Negative 0.12. And so even though we have these numbers here, we still end up getting a correlation value. But here's the problem. We cannot use this number. This number doesn't make sense. Even though one could look at it and be like, oh, it's negative, right? This number still doesn't make sense. The reason is that when we graph the data, we see that there is not a linear relationship. So there's no way that correlation is of value here to compare our stuff. Next, we will go look at simple regression. So in simple regression, we can do the same thing, right? So we'll go over simple linear regression and multiple linear regression in these two cases. In simple linear regression, you have a dependent variable, and which is the y variable, and you have an independent variable, which is the x variable here. Once again, we can graph the data. So we go in here and we will graph the data like this to make sure that there is a linear relationship here, and there should be, because we are doing a simple linear regression here. There's two ways to come up with a model here. You can go to the graph and right click and hit add a trend line. That will pop up this dialog box. Make sure you select it's selected to be linear here, and we will check mark off display equation on chart and display the r-squared value on the chart. When this happens, we can see the equation for simple linear regression right there, and we get an r-squared value of 0.2173. Okay, the r-squared value is a coefficient of determination. This is r-squared is different from the correlation coefficient, which is denoted by little r. Okay, r-squared is called the coefficient of determination, and essentially is used primarily for in the cases of like regression. So this is used for determining how accurately our model, which is this line here, is able to fit in all these data points. R-squared extends from a score of 0, which is not very good, which means that it's not a good model at all, to a maximum value of 1 or 100%. That's when you have all your data points fit into the model. So because our data here has some outliers here and there, we tend to have lower r-squared value. Okay, if all of our data points fit into the line, then we would have an r-squared value of 1. All right. The other way to do a simple linear regression is to use the data analysis tab. Okay, the way to do that is to go to data, click data analysis, and go to regression here. Click OK. You input your y range, input your x range. We have the labels, there are columns, and we want to put the output, let's put the output right here. If we want to look for errors, we can keep residuals. We're not going to do this in this case. And we hit OK. What did I do wrong here? Oh, I probably need to select the value specifically. I was trying to be a little lazy, I guess. Let's see if this works. Okay. Don't have any labels in this case. And we hit OK. And there we get our value. Okay, there we get our value. So our r-squared value, notice that it matches up with our graph. The r-squared, 0.2173. Perfect. This is our r-squared value, and this is the value that shows how well our model is fitting our model, being the y is equal to mx plus b model, linear regression model, is fitting all the data points.